In this video I'll go over the formulas that were given in chapter 3. So starting off with total fall, inches to feet. If you need to find that out in a particular problem, then you start off with total fall in inches up here, length, or also can be called out as distance or horizontal run. I plugged it in there, and those have to be in feet, and then the grade will be in inches per foot, or parts of an inch per foot. If you have grade as a percent, then you use this formula, which requires that the total fall and length will be in the same units of measurement. And this originally I had a times 100 here, like they showed in the book, but I found that to be unnecessary, and I know that when I have a percent, I need to change that to a decimal, and the way we do that is take, if it was 1%, then we would move the decimal 2 spots, 1, 2, because 100 has 2 zeros, and there we go. So that's the number that we would multiply by this, or that's the number that we would use to divide this number. And moving on to mechanical advantage. Mechanical advantage in both of these does not have any unit of measurement, but for force and for distance we're actually going to have the same units of measurement. So for this one, it'll, this resistance and effort will be the same units of measurement for force, and for distance, effort distance and resistance distance will also have the same unit of measurement. And that's what it talked about that here too. So same, that's just my shorthand for same units of measurement. Coming down here to area, that'll be in inches or feet squared. For circle, we got pi r squared, or 0.7854 times diameter squared. Originally I had a pi in there, that was a mistake, so this is the corrected formula for that one there. Does not need the pi in there also, it's just that or that will give you the area of a circle in squared inches or feet. For a cube, it's length times width, and triangle, 1/2 the base times the height, or base times height divided by 2. And again, all of those are going to be in squared inches or squared feet. Volume. Nice thing about volume is all you do is take the area formula and add an h to it, and then you got volume. But the result will be cubed inches and cubed feet. So, and again, we just added the height here for the cube and the cube or rectangle, length times width times height. And perimeter will be 2 times the width plus 2 times the length, and circumference is pi times diameter, or pi times 2 times r, which is the radius, and 2 times the radius equals 1 diameter. And that those answers would be in inches or feet. Moving on to these ones here, we have cubed inches per gallon. So I like this method because you can plug in your numbers, whatever your given is, and you'll know what you need to do, dividing or multiplying. And you have this one here with a constant of 231 cubed inches per gallon. If you're going to convert cubed inches to cubed feet, again, plug in your known, and your constant is 1728 cubic inches per cubic foot. For capacity of gallon to cubic feet, you take your gallons, plug it in there, your cubic feet, you plug it in there, whichever one of those you have, and you multiply or divide depending on where you're at. Dividing if you have this, multiplying if you have this. and use this number here, 7.48 gallons, excuse me, 7.48 gallons per cubic foot. We'll give you that answer. And then I want to backtrack over to here, since we covered those. The book also talked about in study units, I believe it was like 69 and 70, they talked about what would be an easier way to get the, I think it was the gallons for a problem, and they said you know, using these in feet. But what also would make that easier is they combined these two formulas. They took this volume formula and combined it with the gallons per cubic foot formula, and it came up with this, which has all the parts in there like we just talked about. And so this here would give us our cubic feet, this 0.7854 times diameter squared times length. That's a squared sign. I don't know if you can see it here. I'll try to blow this up a little bit here. And that'll give us our cubic feet. And then if you look down here, you got cubic feet times that, which is all they did right here, times a 7.48, and that'll give us the capacity of gallons, or gallon capacity. And the one thing that I thought was kind of cool in the book that they showed us how to do, if you don't have an easy way of converting like 65 inches, it's kind of an oddball, to feet, because these need to be in feet, you just divide it by 12. So you just have to make sure you use your parentheses when you do that. You know, get that number separated so you do the order of operations properly and you get your answer correct. Moving on to weight of water. Have weight in pounds. Put your gallons down here and multiply it by 8.33 pounds per gallon. It'll give you that, or you can work that the other way around, depending on what your knowns are. Moving over to pounds per square foot. Need to make sure when you do this one that we have the area in square feet, not inches. That one was giving me a hard time in the book. I was going over the problems in the book, trying to just make sure I understood what was going on, and a couple times I did it with the inches squared and wasn't coming up with the right thing, and then with the right answer, and then I realized I need to make sure that that's inches or squared feet. So that's something got to look out for. So pounds up here and area right here, whatever that is, and then that'll give your PSF. And then these two are closely related. The PSIG, here we take the PSF and plug it in here, divide it by 144 inches per cubic foot, or I'm sorry, per square foot, and then I'll give us our PSI, PSIG. The two other formulas that are closely related are these two here for waterhead. The one they showed us in the book was this one here. 1 PSIG equals 2.31 pounds. So you can plug it in like so. Put your PSIG here, multiply it by that, and it'll give us the height of the waterhead. Now if you know or if you want to work it this way, you can do it that way. You can plug the height of the waterhead here, or the amount of the PSIG here, and use this constant of 0.433 psi per foot to get your answer also. Put that per foot. Alright. For standard airflow per minute, or SCFM, I broke it down into 3 steps. First was define the volume in cubic feet, which is more than likely going to be this one here. And once you got that, plug that into cubic foot per change. And then this would be a given. In the book they gave us that info there, the changes per hour. Plug that in and that'll give us our total air. Total air becomes cubic feet per hour. And then we also had some other givens. They gave us the number of their grills in the book, and then this is a constant here of 60 minutes per hour. And multiply these two, and then take this number and divide it by this product here, and that'll give us our SCFM. Excuse me. Alright, there we go. Hope this helps out. Let me know if I missed anything, or if something doesn't seem right or is confusing. And thanks for watching.